In this video, we will discuss about midpoint ellipse algorithm in computer graphics. So we can define ellipse like this. If there are 2 points f1 and f2 on an ellipse, we call it as a foci. And there is a point P on the ellipse. The distance between f1 to P, we call it as d1, and the distance between f2 to P, we call it as d2. So in an ellipse, the points d1 plus d2 is always equal to a constant. So we can define ellipse as the sum of distances from two fixed positions foci is the same for all points, that is d1 plus d2 is equal to a constant. So the equation of the ellipse with center xc comma yc and the x radius rx and y radius ry is defined as x minus xc divided by ry the whole square is equal to 1. If you consider xc comma yc, that is center as origin, the equation will become x square divided by rx square plus y square divided by ry square is equal to 1. So when we simplify, we get ry square x square plus rx square y square is equal to rx square ry square. Here you can note few things. Always x is accompanied with ry square, and y is accompanied with rx square. And this similarity or this concept is repeated everywhere in our algorithm. So let us see. The equation of the ellipse, we can just rewrite it as f of ellipse of x comma y is equal to ry square x square plus rx square y square minus rx square ry square. Here, given a point x comma y, we can just check f of ellipse of x comma y is less than 0 means we can say the point is inside the ellipse. If it is equal to 0, we say the point is on the ellipse, and if it is greater than 0, we say the point is outside the ellipse. Now, we will use the four-way symmetry of the ellipse to reduce the calculations. Here, we just divide the ellipse into 4 equal quadrants, and we calculate the top right corner or top right quadrant, and the remaining quadrants we will calculate by using the symmetry principle. Now, this quadrant is once again divided into two regions, region 1 and region 2. When we calculate the points in region 1 and region 2, and when this region 1 and region 2 meet, we say the slope is equal to -1. The slope of the ellipse, we call it as minus 2ry square x divided by 2rx square y. So when these two matches, we say that 2ry square x is equal to 2rx square y. So by keeping all these things in our mind, we can go for generating the algorithm. In this algorithm, we use the decision parameter as usual. So the decision parameter, we have two. It is for region 1 and region 2. Consider that we have plotted a point xk comma yk. Now, in region 1, you have to decide. At each iteration, we increment the x value by 1, and we have to decide whether we have to keep the same y value or you have to decrement it by 1. So here we use the midpoint algorithm. The midpoint between these two is x plus 1 comma yk minus half. So the decision parameter is f of ellipse of xk plus 1 comma yk minus half. If you consider region 2, here at each iteration we are just going to decrement the y value by 1, and we are going to decide whether we have to keep the same x value or we have to increment it by 1. And the decision parameter will be f of ellipse of x plus half comma yk minus 1, because this is the midpoint between these 2 points. The reason is in region 2, if we observe, the x value changes very fast and the y value will be falling very slowly. So we increment x value and we decide whether we have to keep the same y value or decrement it by 1. But in region 2, the value of x will be slowly changing, whereas y value is falling drastically. So we just decrement the y value and we decide whether we have to keep the same x value or we have to increment it by 1. This is the concept of your region 1 and region 2. So we have to plot the points based on this decision parameters. So here if P1k, there is a decision parameter for the region 1. If it is less than 0, we plot xk plus 1 comma yk, else we plot xk plus 1 comma yk minus 1. In region 2, if P2k, that is the decision parameter of the region 2 is greater than 0, then we plot xk comma yk minus 1, else we plot xk plus 1 comma yk minus 1. So these are the concepts we have to remember when you want to generate midpoint ellipse algorithm. Now let us see how to write our ellipse algorithm by using our midpoint circle algorithm. So if you remember the midpoint circle algorithm, in step 1 we initialize x naught comma y naught. The second step we initialize p naught. Then in third step we have an iteration. If pk is less than 0, then we increment pk plus 1 is equal to pk plus 2xk plus 1, and we plot x is equal to x plus 1, else pk plus 1 is equal to pk plus 2xk plus 1 minus 2yk plus 1, and we increment x by 1 and we decrement y by 1, and we have these things. So let us see how to rewrite the circle algorithm into our ellipse algorithm. So initialization, we just initialize to 0 comma ry because the top right value, and p naught, p1 naught we call it as, and we will calculate. Now we just remember this important point here. Here there is an x term. I hope you remember always x term is accompanied by ry square, I said. So we just multiply by ry square. So we will get 2 ry square xk plus 1 plus ry square. So both the terms we multiply by ry square. So here also we have an x term. So we multiply by ry square, and here we have an y term, so we multiply it by rx square. The same thing we will apply here also. This is ry square, and this one you have to multiply by rx square. So let us see the algorithm now. Initialize x naught y naught is equal to 0 comma ry, and p1 naught is equal to, we'll just have ry square minus rx square ry plus 1 by 4 rx square. Then now the iteration step, if p1k is less than 0, so same thing what we worked out here, you can just check it out. P1k is k plus 1 is equal to p1k plus 2 ry square xk plus 1 plus ry square. So we have just added the ry square here, and x is equal to x plus 1. Else p1k plus 1 is equal to the same term we rewrite as it is, and here this yk plus 1 is replaced by rx square yk plus 1. X is equal to x plus 1, y is equal to y minus 1. And where 2 ry square xk plus 1, that is what we have in our term, 2 ry square x square plus ry 2 ry square, and 2 rx square yk plus 1 is equal to 2 rx square yk minus 2 rx square. These statements are the same. Determine the symmetry in 3 quadrants and plot the ellipse points by using the symmetry principle, and repeat the step. So we have seen the condition when it moves from region 1 to region 2, 2 ry square x will become 2 rx square y. So till it is greater than, we repeat the steps as it is. So here we have learnt how to write or how to rewrite our circle algorithm into an ellipse algorithm for region 1. Now let us see how to do it for region 2. So as we discussed already, region 1 and region 2 change will be varying only in few steps. We will see. This is our region 1 code. Now we have to remember 2-3 key points. In region 1 to region 2, when the point moves, so we have to replace x by y and y by x. So if there is a plus x, that is plus, then you have to replace it by minus, because we say y minus 1, and also there is a less than symbol that should be replaced by greater than symbol. So this we replace x by y and y by x. So whenever it becomes y, you have to put a minus over here. This is rx. So you can just write 2 rx square minus 2 rx square xk plus 1 plus rx square, like that it comes. When you rewrite the same thing here, here also this x should be replaced by y should be replaced by x, and so on. So now we will check the algorithm. In region 1, when you replace, you'll be getting let x comma y initializing value. There we stopped in region 1. From there you have to start in our region 2. So the last value of x and y in region 1 will be the initial value for region 2. And we calculate P2 naught. This is nothing but f of circle of x plus half comma y minus 1. Then this is the iteration statement. My less than is replaced by greater than symbol, and p2k plus 1 is equal to p2k minus 2 rx square yk plus 1 plus rx square. Ry square is replaced by rx square, and y is equal to y minus 1. Else p2k plus 1 is equal to p2k minus. So here you have the same minus, this will become minus rx square, and minus 2 rx square yk plus 1 will be replaced by plus 2 ry square xk plus 1. X is equal to x plus 1, y is equal to y minus 1, and these statements are the same. So we will determine the symmetry, and we will repeat till y is greater than 0. So now we got the algorithm for your ellipse, that is with region 1 and region 2. I think it is very easy to learn if you know your circle algorithm. So let us trace this. We start with Rx is equal to 8 and Ry is equal to 6. Since we use Rx square, Ry square and all, I am just calculating those values also. Rx square is equal to 64, 2 Rx square is equal to 128. Ry is equal to 6, Ry square is equal to 36, and R2 Ry square is equal to 72. So now when we initialize, x and y will become 0, 6. And when you calculate P1 naught, the value will be 332. And when x is equal to 0, the value will be, this will be only 2 ry square, that is 72. Since pk is minus, we just go for incrementing x value and we keep the same y value. And we will recalculate our pk, that is pk plus 1 is equal to p1k plus 2 ry square xk plus 1 plus ry square. So it is 72 plus 72 minus 224. Like this we'll get, and here also it is negative. We calculate only 2 ry square xk plus 1 144. We keep the value as it is. For y, we'll be getting the values like this. When you work on this, you'll be getting values like this, and we stop with 7, 3. And when it is stopped, we just move on from region 1 to region 2. In region 2, we start with the point 7, 3, and P2 naught is equal to minus 141. So if you start working with this algorithm, we just get here, we start with x is equal to 7 and y is equal to 3 and pk is equal to minus 151. Since it is less than 0, we come for the else part and we increment x by 1 and y is equal to y minus 1. So we will be getting 8, 2, and this is 576 and 256. Once again we calculate pk, it will be minus 224. So when you recalculate all these things, you'll be getting the points like this. So we'll be getting 8, 1, 8, 0, like that it stops. By combining region 1 and region 2, we'll try to plot it on our graph. So when you plot it, you'll be getting 0, 6, 1, 6, 2, 6, 3, 5, 4, 5, 5, 4, 6, 3, 7, 3. Now we will come to our region 2. So 8, 2, 8, 1 and 0. This is our algorithm. So for more details, you can refer Computer Graphics by Hernan Becker. Have a nice day.